Enzymes are globular proteins and they're known as catalysts, which means they speed up the rate of a reaction. They're quite small in size, they can be reused again and again, so they're quite effective. In today's video, my goal is to kind of explain how they work and what factors affect them. If you imagine we have like two substances or substrates floating around which are going to collide with each other and form a product. I'm going to give the example of sucrose and water. They need to collide with each other with sufficient energy. When this happens, there's an arrangement of the atoms and we have the formation of glucose and fructose. Now, energy is needed for this reaction to occur, and we call this the activation energy. What enzymes do is they lower the activation energy for this reaction to occur. So what happens is the reaction completes faster. The structure of an enzyme is a globular protein, and we've mentioned it has an active site where the substrate binds onto. When the substrate binds into the active site, we have the formation of an enzyme-substrate complex. The mechanism of how an enzyme works, it's been theorized that there's something known as the induced fit model. The best way to describe this is that once you have a substrate which gets close to the active site, it's been said that the active site kind of molds itself so it's the shape of the substrate so that they can kind of join each other in a complementary way. Another theory of how enzymes work is the lock and key mechanism, where you have the substrate as the key and the active site of the enzyme as a lock. So that's another theory of how enzymes work. But we know that what's going to happen is the substrate is going to bind into the active site because of the complementary fit, and then the activation energy is lowered, so the reaction occurs at a faster rate. There are some factors which affect the rate of a reaction. The first one is the temperature. So an increase in temperature increases the kinetic energy of the molecules. They move around more rapidly and they're able to collide with much more energy because of the additional kinetic energy. Having more enzymes available mixed in with the substrate, so a higher concentration of enzymes, is going to increase the rate of the reaction because then there's more active sites available for the substrate to bind into. Increasing the amount of substrate is going to increase the rate of reaction to a certain extent. The more substrate available, the more it will bind into the active site. However, there is going to be a limit because at a certain point all the active sites of the enzymes will be full, but to a certain extent it does increase the rate of reaction before it kind of tapers off. And the pH also affects the rate of reaction. Each enzyme works in an optimal pH, so if it's an optimal pH for the enzyme, it will work efficiently. However, if it's working outside of its optimal pH range, the enzyme is not going to work optimally, so the reaction speed may decrease. To a certain extent, if it's too acidic or too alkaline, the active site of the enzyme could just get destroyed. And the last thing that we're going to talk about now is different types of inhibition. So a good way to control the rate of a reaction, especially when enzymes are involved, is by inhibiting the enzyme to work. There's two mechanisms for this to happen. There's competitive inhibition and non-competitive inhibition. So if we have competitive inhibitors, they have a similar shape to the substrate. So what's going to happen is they're going to compete with the substrate to bind into the active site because they have a similar shape. And then what will happen is the substrate isn't binding into the active site because it's getting blocked by the inhibitor, so we'll have a reduced rate of reaction that way. Another way enzymes can be inhibited is through non-competitive inhibition, and this is where we have a molecule, and what it does is it binds onto the enzyme in a separate area from the active site. And what this does is once the inhibitor binds to this region, the active site changes its shape, so it's no longer complementary to the substrate, so therefore the rate of reaction is reduced.